Hi everybody, so this video is about the multiplication of radicals. So previously we looked at multiplying individual radicals together and how that sort of works, but now we're getting into some of the more complicated multiplication, which you'll see in sort of this table below. So don't let it intimidate you, it's just running through all of the things that we have already done. So there is your distributive law, and the rest are basically FOIL. So that's your sort of standard FOIL. Then you have two examples of shortcuts you can use for perfect squares. So again, you may know this shortcut or these shortcuts, I suppose. It's really the same thing. The only thing that's different is the symbol there. You may know those, you may not. If you don't, FOIL will still work. And then the last is the shortcut for expanding a difference of squares. Again, same thing. You may be familiar with that shortcut. You may not be familiar with that shortcut. If you are and you want to use it, great. If you're not and you don't want to use it, FOIL will still work. But what it essentially boils down to is when you're doing the difference of squares, you're essentially just doing the F and the L of FOIL, because if you'll recall, when you multiply together two brackets that are the same except for the symbol in the middle, the O and the I will always cancel one another out. So then you're really just left with two of the four multiplications with FOIL. So we're doing the same sorts of things that we've been doing previously, just now we're doing it with radicals. So let's go through a series of examples, sort of touching on each of these. I will do the examples using the shortcut method because that's, I think, what will be least familiar to you. But if you don't want to use the shortcut, have at FOIL, it will still work, you will be fine. So let's dive right in. So first up is distributive law. So we have a radical sitting out in front of the set of brackets and then a series of radicals inside. So again, we take what is out front and we multiply it by every term inside. So the first multiplication is root 2 times root 2, which just gives me 2. And then root 2 times positive root 3 gives me positive root 6. Then I look to see if I can make that simpler, and I know that 6 does not have a perfect square factor, so I am done with that one. Moving on to example B, again with a positive radical sitting out in front, we are going to multiply said positive radical into our set of brackets. So the first multiplication we have is root 3 times 6, giving me 6 root 3. Second multiplication, positive root 3 times negative 2 root 3, so that's going to be negative 2. And then the root 3 times root 3 gives me 3. So simplify a little bit further, 6 root 3 minus 6. Okay, so what is sitting out front of the brackets could be positive or it could be negative, like the next examples. So now we have a negative root 2 sitting out in front. So process doesn't change, just have to watch our negatives. So negative root 2 times root 2 gives me negative 2. Negative root 2 times positive 3 gives me negative 3 root 2. I can't simplify that anymore. 2 does not have a perfect square factor, so we are done there. Moving on to the next, we have negative root 3 now multiplying into this set of brackets. So negative root 3 times 7 gives me negative 7 root 3. Negative root 3 times negative 2 root 3 gives me positive 2. And then the root 3's multiply together to give me 3. So negative 7 root 3 plus 6. Again, 3 does not have a perfect square factor, so I can't make that any simpler than it already is. Okay, so there's your examples using distributive law. So now we will move on to FOIL. So this top example is FOIL, and you'll see these bottom examples if you're looking ahead, we get into perfect squares. But again, use the shortcut or don't, FOIL will still work. So let's look at this top example. So 4 multiplications. First, we will do 3 times 4 to give me 12. Then we do outer 3 times positive 2 root 2. So we've got plus 6 root 2. Then we go to negative root 2 times 4 for our inner multiplication, so negative 4 root 2. And then our last multiplication, negative root 2 times positive 2 root 2. So we get negative 2, and then the root 2's give me 2. So then I look to simplify this. There's two things I know I'm going to be able to do. So I know that I've got an integer here, and this will end up being an integer. So that's going to go together. And then I also see that I have 2 root 2 terms in the center. So I know that that's going to go together. So what you do first is up to you. I would probably do 12, and then I would put my root 2's together. So I have 6 minus 4, so positive 2 root 2. And then I would do that minus 4. And then the last thing I would do is put together the 12 minus 4 to give me 8 plus 2 root 2 as a final answer. So again, you may choose to do the simplifying the integer first and then collect everything in the same step. It's neither here nor there, as long as both things get done in the end. So there's your standard FOIL example. So again, the perfect squares and the difference of squares examples can be done using FOIL, or they can be done using the shortcut. So if you'll remember the shortcut, a plus b squared equaled a squared plus 2ab plus b squared. So you square the first, you square the second, and then you multiply them together and multiply by 2 to get that middle term. You'll remember that from the factoring that we did, right? To figure out that middle term of a perfect square, it was 2 times the square root of the first and the square root of the third. So that's where that comes from. So we're going to attempt to use that just to try something different. Again, FOIL will always work. So if you're comfortable with FOIL and you don't want to try a shortcut, stay with FOIL, don't try the shortcut. So let's look at the first one. So the first thing we need to do is square that root 3. So root 3 times root 3, or root 3 squared, is just going to give me 3. Then the middle term, I have to multiply the 2 terms together. So root 3 times 2. I'm just going to jot this down here. It gives me 2 root 3. And then I need to multiply that by 2, double it. So that's going to give me 4 root 3. So then my middle term is plus 4 root 3. And then last but not least, I need to square the third term, which is 4. So that's where I get plus 4. Then collect my like terms. I can put together the 3 and the 4. So that gives me 7 plus 4 root 3. Again, you may prefer FOIL, which is fine. If you prefer FOIL, do FOIL. I'm showing you the shortcut for another way of working. So then on to the next. We've got the same kind of setup. And then we're going to just deal with that negative at the same time. So we've got root 3 squared gives me 3. Then I'm going to multiply those together. So I get root 21. And then I'm going to double that, or multiply it by 2. So I've got minus 2 root 21. Because when I multiply the root 3 by the negative root 7, I've got negative root 21 there. Multiply by 2, negative 2 root 21. And then I'm going to square the last one, which gives me positive 7. And then I'm going to put together the 3 with the 7, giving me 10 minus 2 root 21. Okay, so on to the last. So last but not least, we've got 2 difference of squares. So again, remember the difference of squares simplification, or the shortcut. A plus b times a minus b, a squared minus b squared. Again, essentially doing the f and the l only of FOIL. This will probably be a shortcut that more of you will want to adopt, but maybe I'm wrong. Again, FOIL will still work. This shortcut, more so than the perfect square shortcut, will come in handy for our next topic in the unit. So again, if we just do first and last multiplications, we've got 3 times 3 giving me 9. And last is root 2 times negative root 2, giving me negative 2 for a final answer of 7. Again, difference of square is much easier, so we don't have to worry about the O and the I of FOIL. They will cancel one another out. So we just do the first, the last, call it a day. Next example, we have the first multiplication being 2 root 3 times 2 root 3. That gives me 4. The root 3's multiply together to give 3. And then the last multiplication, negative 5 times positive 5, gives me negative 25. Simplify that down. We've got 12 minus 25 to give us negative 13. Now, note, these give you integer answers. That's really important for the next section. So just pay attention to that. Okay, so those are all of the methods that we're going to talk about for multiplication of radicals. So again, these last ones, if you prefer to just FOIL them, FOIL them. If you want to adopt the shortcuts, I encourage you to adopt the shortcuts, especially the difference of squares one. That one will be really handy come next unit. All right, and that's the end of this video. Thank you.